Welcome to The Explainer. Today, we are diving into something that sounds straight out of science fiction, using quantum computing to build a hyper-accurate digital copy of your body. It's called a metabolic avatar, and it could totally change the future of personal health.
So, think about your health app for a second. It does a pretty good job of telling you what happened yesterday, right? But what if it could reliably predict what will happen to your body next week, even if you forget to log a few meals? Well, that's exactly what we're talking about today.
All right, so this idea of creating a digital twin for your health, it's been around for a while. But for all its promise, the reality has always been stuck, held back by one really big problem.
To try and crack this, scientists developed what they call the Personalized Metabolic Avatar, or PMA. Basically, it's a computer model that learns your unique metabolism, how you respond to food and exercise, to predict your weight. It's a powerful idea, but in the real world, these models have a critical weakness. And here's that weakness. The trouble is, these classical computer models are a bit like a fussy chef. They need perfect, clean ingredients to work their magic. But our lives and the data we create are, well, they're anything but perfect. They're messy. You know how it is. We forget to log a meal, we get sick, and our whole routine goes out the window. The scale gives a weird reading one morning. Classical models get completely thrown off by this stuff. They tend to overreact to bad data, which leads to predictions that are unstable and, let's be honest, not very useful at all.
So, how do you build a model that actually thrives on messy data instead of breaking down? Well, this is where it gets really interesting. Researchers found the answer by turning to a completely different kind of computer, a quantum computer.
By swapping out the classical engine for a quantum one, they created the Quantum Metabolic Avatar, or QMA. It's powered by something called a quantum echo state network. Now, the key difference here is that instead of just following one logical step at a time, it explores countless patterns in your data all at once. It can see connections a normal computer would just completely miss.
And this just shows you the insane efficiency of the quantum approach. To get enough memory to store all the complex patterns in your health data, a classical network might need, say, 500 different nodes. The quantum network, it does the same job with just 5 qubits. That's a 100-fold leap in efficiency. It's incredible.
The researchers put it this way. Thanks to these unique quantum dynamics, the model can see much richer patterns in your data over time, and it can do it without getting all bogged down and complicated. So, in short, it's just smarter, not bigger.
Okay, so the theory sounds great, but how does this quantum avatar actually perform in the real world? To find out, researchers set up a head-to-head competition. They fed both the classical model and the new quantum model the exact same health data from 6 real people.
The first test tackled a really common problem. What happens when you're a new user and the app just doesn't have a lot of your historical data to learn from? Which model can make better sense of a short history?
The results were pretty immediate and very clear. Even with just a little bit of data to go on, the quantum model was way more accurate. On average, it had a nearly 32% lower prediction error than the classical one. It's just much better at learning on the fly.
That's impressive, for sure. But here's the real test. The researchers then simulated real-world chaos. They intentionally added outlier data points, you know, those weird measurements from a sick day or after a holiday feast, to see how each model would handle the noise. And the result? It was absolutely astonishing. When it was faced with this noisy, messy, real-world data, the quantum model wasn't just a little better. Its prediction error was a staggering 76% lower than the classical model. This is what that 76% improvement actually looks like. I mean, look at that. The classical model's error rate just skyrockets. Its performance completely collapses when it sees those outliers. But the quantum model, it just stays incredibly stable. It seems to instinctively know the difference between a real trend and just a random blip. And the raw numbers here in the table are even more stark. I mean, look at this. The classical model's error score explodes to almost 23. The quantum models, it holds steady at just 2.6. That, right there, is the definition of a robust system. So the huge advantage for the quantum model wasn't just about it being a little bit better. It was really about 2 things happening at once. The classical model's performance completely fell apart under pressure, while the quantum model simply didn't. It just stayed stable and reliable no matter what they threw at it.
So this isn't just some abstract science breakthrough. The development of a truly robust quantum metabolic avatar has some pretty profound implications for the future of our health.
I mean, just imagine the possibilities here. We're talking about health apps that can give you genuinely trustworthy, personalized advice in real time. For researchers, this technology could be a game changer for modeling rare metabolic diseases where there's not much data. It could analyze incredibly complex things like your gut microbiome, or even estimate your future risk for conditions like type 2 diabetes with so much more accuracy.
So the takeaway from all this is that the digital twin is finally growing up. It's evolving from a neat concept into a genuinely reliable tool. And the key is that it embraces, rather than fears, the messiness of real life. It makes personalized health predictions something you might actually be able to trust.
And that leaves us with one final, pretty big thought. As these digital versions of ourselves become this powerful and this accurate, what are the next great mysteries of our own bodies that we should be asking them to help us solve?